Hello everyone, I welcome you all to the next video lecture. In this video lecture, we will be learning about chance and then probability. Let's begin. First of all, what is a random experiment? A random experiment is an experiment for which the outcome cannot be predicted with certainty. So such an experiment where we cannot predict the outcome with certainty is known as a random experiment. Like when we toss a coin and make the call, we cannot control the result of the toss. We cannot get a head if we want one. Such an experiment is called a random experiment. Head or tail are the two outcomes of this experiment, right? So why can we call tossing of a coin a random experiment? Because we cannot predict what will we be getting. We can get a tail also, or we can get a head also. So these two are the outcomes. Tail or head are the two outcomes of this experiment. But it is a random experiment because we cannot predict its result. Now we need to try these. If we try to start a scooter, what are the possible outcomes? So when we try to start a scooter, what can be the possible outcomes? The possible outcomes can be that whether the scooter will start or it will not start. Now the other one is when a die is thrown, what are the 6 possible outcomes? So we know that a die has digits from 1 to 6. So the possible outcomes will be either 1 or 2 or 3 or 4 or 5 or 6. So one of these will be the possible outcome. Will be the outcome that we will get. The possible outcomes being 1, 2, 3, 4, 5 and 6. Next one is when you spin the wheel shown, what are the possible outcomes? So here we have a wheel and we are given some A, B, C, these 3 outcomes. So what can be the possible outcomes if you spin this wheel? We need to list them. So either it can be A, or the possible outcomes can be A, B or C. Any one of these can be the answer when we spin it. You have a bag with 5 identical balls of different colors and you have to pull out, that is, you have to draw a ball without looking at it. List the outcomes you would get. So we have this bag, right? We have this bag and it has 5 identical balls but of different colors. And we are going to draw a ball out of it without looking at it. So what are the possible outcomes that we can get? Either we can get a white ball, a red ball, this B ball, either black or blue or any color, brown, and this green ball or this yellow ball. We can get any one of these 5. These are the possible outcomes. Now, what are equally likely outcomes? So, equally likely outcomes are those which have the same chance of occurring. So, the outcomes which have the same chance of occurring are known as equally likely outcomes. Equally likely outcomes. As we increase the number of tosses more and more, the number of heads and the number of tails come closer and closer to each other. Same with the die. When tossed a large number of times, the number of each of these 6 outcomes become almost equal to each other, right? This is very easy, obvious. This is very obvious that if we are going to toss a coin more and more, then the number of heads and the number of tails, they also come closer and closer to each other. Similarly for a die. Now, in such cases, we may say that the different outcomes of the experiments are equally likely because they have equal chance of occurring. In these two experiments, we can say that the outcomes, all the different outcomes, they are equally likely because they have the same chance of occurring. This means that each of the outcome has the same chance of occurring, as I told you. Now, what is an event? Each outcome of an experiment or a collection of outcomes make an event. So what is an event? We can say that each outcome of an experiment or a collection of outcomes make an event. For example, let's take an example. In the experiment of tossing a coin, getting a head is an event. Getting a head is an event and getting a tail is also an event. So the experiment, the collection of outcomes or each outcome, they make an event. Like for an example, when we toss a coin, we are given 2 events like getting a tail or getting a head. Both of these are events. In case of throwing a die, getting each of the outcomes 1, 2, 3, 4, 5 or 6 is an event. So in the case of die, all these will be events. Now what is probability? Now we are heading towards probability. So probability is actually the likelihood of occurrence of an event. Probability is the likelihood of occurrence of an event, and event is a set of outcomes of an experiment. I already told you. So what is the formula for calculating the probability of an event? When the outcomes of an experiment are equally likely, the probability of an event is given by, when the outcomes are equally likely, that is they have the same chance or the equal chance of occurring, then in such cases we calculate probability by this formula, that is probability of an event is given by dividing the number of outcomes that make an event divided by total number of outcomes of the experiment. So the number of outcomes that make an event divided by total number of outcomes of the experiment. This is the formula for finding the probability of an event. It will be more clear when we will do an example. So in probability, consider the experiment of tossing a coin once. What are the outcomes? So we are going to consider an experiment, and in that experiment we are going to toss a coin. What are the outcomes? There are only two outcomes we know. When we toss one coin, there can only be two outcomes, that is either a head or a tail. Both these outcomes will be equally likely because both of these will be having same chance of occurring. Probability of getting a head equals to 1 by 2. Then what is the probability of getting a tail? Probability of getting a tail is also 1 by 2. Here, like this. In this video, you can see that this is how a person is tossing a coin, and either he will be getting a tail or a head. The probability of getting a head is also 1 by 2, and the probability of getting a tail is also 1 by 2. So throwing a die. Now time is to throw a die. In this next one, we are throwing a die, and a die is marked from 1, 2, 3, 4, 5 and then till 6 on its faces. One number on each face. Now if we throw it once, what are the outcomes? We know that when we throw a die only once, the outcomes can be 1, 2, 3, 4, 5 and 6, right? Thus there are 6 equally likely outcomes. These are the 6 equally likely outcomes. Now we are asked, what is the probability of getting the outcome 2? What is the probability of getting the outcome 2? So how are we writing it as 1 by 6? This is because we know that the total number of equally likely outcomes are 6. There are 6 equally likely outcomes in this experiment, that are 1, 2, 3, 4, 5 and 6. So in the denominator we will write 6, and for this question we need the probability of getting the outcome 2. So what are the number of outcomes giving 2? There is only one face that has 2 written on it, so it is only 1. So it will be 1 by 6 by this formula, number of outcomes giving 2 divided by number of equally likely outcomes equals to 1 by 6. You can see this is a die having 1, 2, 3, 4, 5, 6, these digits written on each of its face. Is getting an even number an event? Since an even number would be 2, 4 or 6, getting an even number is also an event. So getting an even number when we throw a die is also an event because we can get 2, 4 or we can get 6. These 3 are the even numbers that are present on a die. Now what will be the probability of getting an even number? So for finding the probability of getting an even number, total outcomes we know that 6, 1, 2, 3, 4, 5 and 6. And how many are the even numbers that we can get? The number of outcomes that make the event is getting an even number. These can be either 2, 4 or 6, that is total 3 such outcomes. The probability will be 1 by 2. 3 by 6 or 1 by 2 by the formula number of outcomes that make the event divided by total number of outcomes of the experiment. Now we have an example. Example number 3. We are given that a bag has 4 red balls and 2 yellow balls. The balls are identical in all respects just except the color, other than the color. Now a ball is drawn from the bag without looking into the bag. What is the probability of getting a red ball? So first of all, we need to find the probability of getting a red ball. Total balls, we have 4 plus 2, that is 4 plus 2, that is 6 balls. And among them, red balls are 4 and yellow ones are 2. We need to find the probability of getting a red ball. P of a red ball, probability of a red ball. It will be how much? Using the same formula. So number of outcomes that are giving a red ball is 4 divided by total number of outcomes, that is 6. So it is 2 by 3. The probability of getting a red ball is 2 by 3. Now we are asked, is it more or is it less than getting a yellow ball? So the probability of a yellow ball will be how much? We can find it just like we found out the probability of red ball. For a yellow ball, it will be the number of outcomes that provide yellow is 2. 2 by 6, total number of outcomes are 6. That is 1 by 3. So which is less than which is less than the other, or which is greater than the other? You can see that 2 by 3 is greater than 1 by 3. That is the probability of getting a red ball. This is greater than probability of getting a yellow ball. Is it more or less than getting a yellow ball? It is more than getting a yellow ball. Right? This is how we found out, just using the same formula that I told you. Now, chance and probability related to real life. So we have studied about chance, probability, events, outcomes, all of these. Now, how are these things related to our real lives? You can see that first is given as to find characteristics of a large group by using a small part of the group. By using these concepts, we can find the characteristics of a large group by using a small part of the group. So I'll give an example related to this. During elections, an exit poll is taken. This involves asking the people whom they have voted for. When they come out after voting at the centers, which are chosen offhand and distributed over the whole area. This gives an idea of chances of winning of each candidate, and predictions are made based on it accordingly. So you can see that this is actually an example where we use this chance and probability, and it is related to our real life. It is related to our real life when we vote. We can make a prediction that who will win. We're using just a small part of the group. Another one is Meteorological Department. So how does Meteorological Department works? It predicts weather by observing the trends from the data over many years of the past. So this is also an example of the same chance and probability that is related to real life. That Meteorological Department, it predicts weather by observing the trends. Observing all the trends from the data over many years in the past. So this was all about chance and probability. We have learned a lot many things related to probability, chance, events, outcome, the formula for finding probability, and at last we also did some questions related to finding probability of some events. And we found out that what are some of the applications of these chance and probability in our day-to-day in our real lives. In the last video lecture, we will be doing a quick revision of all the concepts that we covered in this chapter. We will meet in the next video. Till then, bye-bye.